Uh, huh. All right, that's a way to do it, I guess. Independent agents. And part of that is going to be obstacle avoidance. Ugh. I gotta put up this thing. There we go. Start Amanusis Banish. There it goes. Oh yeah, I should check this out. Yeah, still just 12. Okay, that makes sense. Okay. This back. Do a little Discord announcement. I really wish there was an easy way to link what's it called? YouTube stuff, instead of usually I have to click on this and then go over here and then copy the link and yada yada. Okay. I'm sick, so I'm sniffly, and I dislike it to a high degree. Either that or it's like allergies or something, I don't know. Question. Okay, it does just do that. Yeah, let's break it down a little. Grab the script, undo that. Get rid of this. I'm no longer testing that. Spectre's up there. First things first, I need to do this out. Let's do... Give me 1 second, I'm gonna grab something. Sneezy today. Okay. So, here is my current plan for this. I want people walking around, and I want to give them their own sense of local pathfinding. Might be a little loud here, buddy. There we go. I want a little bit of local pathfinding. This is a very simple example that I put together at some point. I don't remember when, but all it does is it tries to move in one direction and tries to stay away from the walls. And it works well enough, you know, but I want to take this idea a bit further. Yeah, as you can see, it just moves. And then it gets to an issue when it can't go up anymore because it doesn't have the way to... It doesn't have a good way to go the other direction. Let me get rid of this thing that's spewing out data. Yeah, let's just comment that out. Okay. Okay, so honestly, I might need to make like a whole different. Yeah, let's do. Create new scene. We're going to do a LiDAR test. So we're going to have a sprite. This is going to be a background. We're going to give it a noise texture. We're going to set the offset, and we're going to set it to the screen size. That's a little large, a little bit too much. Go ahead and get the color ramp, make it constant, zip this to halfway. Actually, I want it a little bit less, and then I want the Perlin noise because I like Perlin. And then we will transform, scale it by 10, and turn off the filter nearest. I need to set that as a default, man. Texture, rendering, textures, default, nearest. Okay, much better. I like the clean cut edges a lot better. I'm actually going to bump this up to 16 by 16. And go over here. Uh, 700 divided by 16. There you go. Now I need to change the frequency so there's actually some variance in here. That should be good enough. Well, let's change the seed because I need some connecting pieces. Okay. This can work. All right. Oh. All right, so this is going to be the background. It's ugly, but it'll do. Here, we'll do that. Make it a little less ugly. Okay. Background. And then I'm gonna need a nice little, let's do a character body. Let's do a rigid body. And then I gotta add all the usual suspects. Do a circle shape. Take this whole thing, move it like here or something. We'll do a polygon. Keep it as polygon. We'll make the color, I don't know. Let's get like a good red or something. Palette. I didn't mean to put earthy. Why did that pop up there? Start your engines. Okay. We will, yeah, I guess. First I'll get. Wow, I hate you. Alright, new one, just. Yeah, let's get a weirdo red here. eh, 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 eh. Go in here, change the data to make it easier to fit my brain. -10, 10, 0, 0, 10, 10, 0. Okay, now it's a perfect diamond, which makes me slightly happier. Size a half a block, I believe it should be. No, it's the size of a block. Yeah, that works. Now, ideally, on top of this, we're going to want a LiDAR thing, and that's going to have a raycast. So, now that we have the scene set up, let's go plan some stuff. Where was that? I want here, this, yeah. So this is what I am going to base it off of. So there's a couple different pieces here. There is the let's see, what's the best way to describe this? So there's a way to detect the environment. There is a way to choose what's valuable from the information detected. And then there is the actual movement to get closer. Right? So depends on two forces. So it has an attractive force and a repulsive force. Right? That makes sense. So the movement part has attractive forces. Okay, so it has attractive forces, it has repulsive forces. And it's also going to need noise. So this is going to need a valuation function. Okay, that works. This is going to need some kind of sensor. Just touch that there. So let's look at this. Local navigation methods, LiDAR. I'm interested in vector filled histogram, but I don't really know about that too much. So for this, we can use either a LiDAR or a vector filled histogram. The valuation function, that's not a big deal. I think I could just do like a inverse something or other. I can't remember what it's called. It's like a 1/, function. So these are the different pieces that I can see. Oh, okay. So I think something I'm also going to have to consider in this is memory. So let's first start trying to do this. Export our number of raycasts, set that equal to 1. Okay. Just want to make sure that was still working. Bye. So the LiDAR, we have a number of raycasts. We'll do our memory. Do 10, 20. And then I'm gonna need something, some way to determine what's good and bad. I would rather that be modular, but I don't really know how I can do that. So, I guess blah. Okay. So noise is going to be sort of last on the list. So we're gonna need something to check point. And let's see. If I want to store these in an array, I might have to make like an object that's basically a struct of a couple different things. So what is the point? Let's need like what is it? What does the LiDAR point need? What's it gonna need to remember? It's gonna need to remember the point and how much it wants to go towards it. So the actual location. Let's just do this. Maybe we won't use it, but we will at least LiDAR point. So the position, which is, we'll just do a vector 2, and then the value of the point, which will be making an int. Starts out at 0. Do we need anything else? So I could just contain that in like a small dictionary thing, or even just sequential in a in an array, or 2 arrays rather. Let's see. For now, we'll just do this, but in that case, I'm gonna need to point valuation. For this, we're gonna need the. We'll take the point as a vector. Then we'll take the type. Well, for now, we'll do something else. So first, we'll make a get type, which takes the point and returns a float. This should also return a float. Okay. We will make a memory array. We'll do this as memory limit. I don't even want to do that for now. If it's a LiDAR, our angle increment, we'll do like tau over 16. And if you want to do yeah, we'll just do it once a frame. I messed up my microphone settings. I think it was like that. Close? I don't know. Whatever. We'll figure it out. Okay. Question is, this might need to have a reference to world reference. Well, let's do it this way. At onReady var, not ready, on var world equals get path world reference. There you go. Sorry, get node. Get node. God, I'm sniffly and tired today. Man, it's a Sunday for sure. Okay, so for now, all we want to do when we check a point underscore process checkpoint. All we want to do when we check a point is raycast. I should probably actually reference this somewhere, eh? We get the raycast. And we're gonna do get collision point. Point position is that we're going to if point position. Well, no, it should always return something because get collision point should return the end of it, right? Maybe. Okay, so we get the point position. Point equals LiDAR equals new LiDAR point. We get the point position, we get the point valuation. Give it the point position. And then the new point gets the point position and the value. And we just add it to memory. If memory is too big, and we knock it off. Okay, so now we got to do these functions. Our distance is going to be global position dot get distance to point. We will do world dot texture and make sure it's a texture. 2D. World data, I guess. World text just get image, get data, and if world data dot world pixel, that's going to be world data dot get pixel. Right? Is that in data? Might be an image. Pixel V, make my life a little easier. Point. Pixel.art is greater than 0.5. How do I get type though? How do I make a type? You get point value. So in this case, we want, we'll match the color with black, I guess.